Hey everyone, this is the first set of notes for Unit 6. So Unit 6 is super fast and crazy. We kind of get it all done within the 2 weeks before Christmas break. So make sure if you have questions that you ask me or come into tutorials. This unit is about chemical reactions. So today's notes is about the different types of chemical reactions that we will study this year and we'll study next year if you take Chem 2. This set of notes is a little bit cheesy, but I teach it this way because you will remember the different types of reactions. So bear with me, it's kind of cringy, but it will help you remember. So the 5 main types of reactions. The first type is called synthesis. We are going to call it marriage or pretend it's marriage, and this will make more sense in a second. Then we have decomposition. If we are making a metaphor for it, I guess it would be divorce. Then we have single replacement, which we're gonna call stolen sweetheart. Then I have double replacement, which we're gonna call date swap. And finally, I have combustion. We're gonna call that the player. So the 5 main types of reactions, the actual names that you need to know are synthesis, decomposition, single replacement, double replacement, and combustion. So synthesis we said was marriage. The basic equation for this type of reaction is gonna be A plus B, and that arrow is telling me that a reaction happened, and it's gonna form AB. So that is 2 separate elements, and there's some type of reaction that happens, and they form a compound. So A is an element, B is an element, a reaction occurs, and it makes AB. AB would be a compound of 2 or more elements. So for this story, we have a guy and a girl, and they get together, they get married. That's what happens in this type of reaction. Next, the compound produced is going to be larger and more complex than the reactant. So here's a real life example. I have 2H2 plus O2, and when they combine and form a reaction, it would get 2H2O, so 2 water molecules. That product is more complex than the reactants. Next we have decomposition. We're calling this divorce for the sake of the notes. So I have 2 people and something happens and they split up. Okay? Again, super cheesy, but you will remember this. Your basic equation is going to be AB. There's a reaction that happens and you get A plus B. They're separate at the end. So I have a compound, some type of reaction takes place, and the 2 elements in the compound split up and become single elements again. So the exact opposite of synthesis. This is going to be the breakdown of a larger compound. So in my example, I have 2H2O, which is just water, breaking down to 2H2 plus O2. Okay, next I have single replacement. For this story or set of notes, we're going to call it stolen sweetheart. My basic equation is AX plus B to get BX plus A. So AX, that's a compound, right? And then we're saying plus B. B is a single element. What happens is that they basically switch. So in this little story, I have a guy and a girl, okay? And then some random person comes along and she decides she wants to be with him instead. And then Mark is all alone. So the only thing that happened was that A switched partners. The free element must be the more reactive element for the reaction to occur. So Pierre was more likable than Mark, okay? The further apart 2 elements are on the activity series, the more likely the higher one will replace the lower one in a compound. Here's my example. I have 2K plus 2HCl. So in this example, my K and my H are just switching places. So now I have 2KCl plus H2. This is the activity series that I was talking about. The farther up something is on this series, the more likely it's going to replace something that's below it. So if I'm looking at lithium, that's all the way at the top, it's super reactive. It can replace anything that's below it. If I say, is iron or nickel more reactive, then I would say iron. Or you could say, is chromium more likely to replace iron or zinc? And it's more likely to replace iron because it's above it. The next type of reaction is called double replacement. We're going to call this date swap. So I have AX plus BY to get AY plus BX. So all that's happening is your elements are switching places. So let's say I have this couple right here, then I have another couple right here who's playing volleyball. Something happens, they decide they don't like each other. Both sets of couples are switching partners. So the same thing happens if you're thinking about chemicals. I have A with X, but now A is going to be with Y on the product side. B and Y were originally together, but now I have B and X together on the product side. It always involves the formation of a molecular compound, such as water, and a precipitate or a gas. Okay, so here's my example. 2Ki plus PbNO3 to get PBI and 2KNO3. So it looks really complicated, but if you just look, K and I were originally partners, and P and NO3 were originally partners. The only thing that happened was the K and the PB, which are my two metals, they just swapped places. That's all that's happening. It's really not too complicated, okay? Remember the little AQ at the bottom? That means aqueous, so that means it's dissolved in water. S is for solid. Okay. Lastly, I have combustion. We're calling this the player. So we all know who those people are. They were friends. Some guy comes along. He ends up being with both people. Okay, so if I look at what this reaction would look like, it would be AB plus O to get AO plus BO. So A and B are both going to partner or react with the O. They will always produce oxide compounds and energy, which means they're exothermic. So exothermic means they're releasing heat. In my example, I have CH4 plus 2O2. A reaction happens. That's what the arrow is telling me. And then I have CO2 plus 2H2O plus energy. Energy is usually heat of some sort. Combustion to me is one of the easiest ones to decide because it will always, always, always have CO2 and H2O as a product. So if you see those two things on the product side, in your mind, you can automatically think, okay, this is a combustion reaction. And it might not always say energy on it, so I wouldn't specifically try to look for that. Just look for the CO2 and the 2H2 or the H2O. Okay. We also have this little flow chart that's super helpful. I believe this is on your notes, but I can't remember. So you can ask yourself these questions. Is there only one reactant? If you say yes, then it's a decomposition reaction. If you say no, then you go to the next question. Is there only one product? If you say yes, there's only one product, then it is a synthesis reaction. Okay? If you say no, and there's a O2 in the reactant side and CO2 in the product side, that's going to be a combustion reaction. If you say no to that question, and there's a single element and a compound on the product side and the reactant side, that's going to be a single replacement reaction. If you say no to that last question, you're going to say, are there two compounds on both sides? If you say yes, that's a double replacement reaction. Okay, so go ahead and make sure all your notes are filled in and work on your worksheet for today.